Hey there, so this is part 3, and will you look at what's happened? The evil bad cat has caught poor Waddles and Cedric and tied them up to a smooth pulley using a light, inextensible rope, as cats often do. Now, Cedric and Waddles can only escape if they can work out the tension in the rope, and then they can work out, knowing the tension will help them to escape by being able to cut the rope in the right way, and then they'll fly off or something. They didn't give me their full plan because it's a secret. Right, so let's look at what we do. Well, because we have the light inextensible string and the smooth pulley, we can treat this as one system. Now, obviously, Cedric weighs more than Waddles, so the system is going to accelerate in this direction, okay? So if I now use F equals ma for the whole system in the direction of acceleration, I get 2g, which is Cedric's weight, minus g, which is Waddle's weight, because acceleration's coming around this way, the system's accelerating this way, so this force is pulling us positively in direction of acceleration, this force is going against, and we can ignore the tensions because we're treating it as one particle system, okay? So all of that's equal to the total mass times its acceleration. Putting those values in, I then get acceleration as 3.27. I'm assuming I'm using g here as 9.8, acceleration due to gravity. Okay, now we have the acceleration of the system. To calculate the tension in the rope, we simply use F equals ma. We could use F equals ma for either, but I'm going to use F equals ma for Waddles. Waddles is accelerating up, going wee. So F equals ma upwards for Waddles. We have T, the force driving Waddles up. Acting against that, we have gravity. Okay, his weight is 1 kilogram, so that's just 1 times acceleration due to gravity, 9.8. So that's acting down against this motion. That's equal to Waddles' mass multiplied by the acceleration. Note that every time, year 12, I'm saying the equation I'm using, what I'm using it for, and the direction. Very important. Okay, so the tension we get by doing 3.27 plus g of 9.8, we get 13.07, and reveal a smiley face, which looks like me when I used to have hair. Now, we could have used F equals ma for Cedric, and if we pull this down here, we've got a little checkbox. F equals ma for Cedric acting down, because that's in direction of his acceleration. So we've got 2g acting in direction of acceleration, we've got tension acting against that, and that's equal to Cedric's mass times the acceleration, and that all gives us 13.06. There is a slight difference, obviously, between my two answers, but that's simply due to rounding. Okay, let's see what happens in part 4, shall we?